So, welcome back to the second lecture on YouTube. And today I'm going to kind of just review a few basic definitions. These are not new, these are things that we learned yesterday for the most part. There's one little new one, but I just want to kind of go over it real quickly, rehash the definitions. We have the atomic number, which we call the Z number. It's the number of protons. It determines what an atom is, and it is used to arrange the periodic table. The periodic table is in order of smallest to biggest atomic number. And so if you were looking at an atomic symbol, the Z number, the atomic number, the proton number, that is the one on the bottom right there. Mass number was the second word we wanted to review today. That is the weight of an isotope. And that equals the protons plus the neutrons together. So that would be at the top number on the left of an atomic symbol. And it's often abbreviated A. I forgot to write that on there. That's abbreviated Z. This is abbreviated A. Isotopes, again, are two or more atoms of the same element with different weights due to different numbers of neutrons. Carbon 14, carbon 12, nitrogen 14, nitrogen 13. These are all different examples of different kinds of, these are isotopes of one another, these are isotopes of one another. Same element, different weights. The last one, and this is the new one, this is one we haven't covered yet, and it's very similar to a lot of these others. It's atomic mass. The atomic mass is actually the number on the periodic table other than the atomic number. If you look at the periodic table, like on hydrogen, it'll say 1 for the atomic number, but then it'll say like 1.001 or 1.0078, depending on how many digits your periodic table goes out. And that is the atomic mass. And what I want you to understand is that is the same as the mass number, but it's not for a single isotope, it's an average number for all of the different isotopes. So you might have carbon 12 and carbon 13 and carbon 14, and you take all of those and you put it on a scale, you divide by how many there are, and they on average weigh about 12.011. That would be your atomic mass. And that's useful for a lot of things, but it's not useful in this chapter. Do not use that in this chapter. That number besides the atomic number, the atomic mass, we're not going to use that. That's an average. It's like trying to figure out how like what you weigh by what the average mass of people in the room is. It's not very useful to find out individual isotopes because it's an average number. So that will be that for those.